Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 14E assignment. Okay? First one here, number 5. 5% of electric light bulbs are defective at manufacture. 6 bulbs are randomly tested with each one being replaced before the next is chosen. Determine the probability that 2 are defective. Okay, so now what we're going to do on this one here is we're going to show you how to do this with the TI-84. Okay, and there are directions in our textbook as to how to use a Casio or a TI Inspire, but we have a class set of 84s and a lot of people have those, so I'm going to show you how to do that. So this here is a chart actually that I put on the notes. I thought this would be kind of handy for us to be able to use to try to figure this out. So let's try this. So exactly 5% of the bulbs are defective. So here's what we want to do. To calculate the binomial probability for exactly a particular number of successes, in this case 1, we're going to use binom PDF. Okay, so what we want to do is we want to bring up our calculator here. I'm going to try to figure out, there's really not a great place to put this, but all right, I'm just going to put it here. So to get into that, you do second variables because these are distributions. Okay, and we go down until we get, I think, to like A. There we go. So we want binom PDF. If you'll notice this, like to get exactly a number, you want to use the PDF one. Otherwise, if you want to get at least this many or at most that many or something like that, then you're going to use the binomial CDF. So to get the exact number, like if it's just one, exactly 2 are defective, you're going to use PDF. Otherwise, you'd use the CDF. Okay, so for this one here, we'll do binom PDF. Now, some of your calculators will actually have you say the number of trials, the P probability, and then the X value, which is explained here. Again, just don't have enough room to put that all in there, but that's all right. We'll make it work. There. That's because we can see everything that we need to see on this one. So the number of trials, we're doing 6 bulbs are randomly selected, so we're going to do 6. The probability of that bulb being defective is 5%. So we want to put that in as a decimal. So move the decimal over twice. It's 0.05. Okay, and then the X value is the number of successes that we are looking for. So in this case, the successes are going to be 2 are defective. Okay, now this would be different if it said 2 worked the correct way, because then we'd have to change our p-value to 0.95, or we'd have to switch anyway. It's not asking us to do that. So they're trying to be nice here. So anyway, put all that in there, and we're going to push paste, and then it's going to paste it into this here. So some of you are going to get this binom PDF, and it's just going to start with the parentheses. So the first number is the number of trials, 6. Second number is going to be P, the probability of success, and then the third number is going to be the number of successes that you are trying to get to, which in our case was 2. Okay, push enter, and we get about 3.1%. Okay, so that is 0.0305. Okay, now for part B, we're going to do at least 1 is defective. So this one here, it's nice because this one gives you all the possible outcomes that you can possibly come up with here. So this is what we're going to use for this one here. At least 1 is defective. So here's how you have to look at this. I think that like more than or at least, these are the trickier ones because you have to do the complements of these. So what we want to do is you want to think of, so what they're saying is calculate the probability at least 1 is defective. Okay, so on this one here, our probability here would be, so we're looking at the probability that X is greater than or equal to 1, right? At least 1 is defective. Okay, so what this saying here, that's going to equal 1 minus the probability of less than or equal to 4 being defective. Okay, so in our case here, we're going to do 1 minus the probability of x is less than or equal to 4. So we're going to do the binomial CDF on this one. Okay, so we do second variables, which is the distribution. This one we go down to, I think it's B. Binomial CDF. Okay, and then the number of trials is still 6. The number of, the probability of them being defective is 0.05. So those are both the same as the first one. And then now the X value, this is where we got to put in, this is where we're looking at this one here. I don't know why I did less than or equal to 4. Oh, you know why I did that? Because I copied that. So x is less than, we want to know when x is greater than or equal to 1. So this would be, so you're going to actually take away 1 from that. So x is going to be less than or equal to 0. So what's the probability that none of them will be defective? Okay, so in our calculator case here, our x value is going to be 0. We paste that in and we push enter, and that's a 73.5% chance. So 1 minus 0.735. Okay, so then we actually have to subtract those two. Okay, so we do 1 minus our answer, and we get 0.265. Okay, so about 26.5% chance that at least one is defective. Okay? Okay, I know that's a little bit weird. We'll do a few more on this here, and that should hopefully help out. Okay. Let's see here. Let's look at number 2 here. Okay, I'm putting this over here on the side, so maybe we can use our calculator over here. Number 3, local bus service does not have a good reputation. The 8 a.m. bus will run late on average 2 days out of every 5. For any week of the year, taken at random, find the probability of the 8 a.m. being on the 8 a.m. bus being on time all 7 days. Okay, so this is an exact number, so that's going to be, this first one here is going to be, this part A here is going to be this. So that's, we're going to use an A for that one. Okay, so we use our calculator here, second variables, go down to binomial PDF. Uh-oh, sorry, messed that up. And there it is. Okay, so number of trials. Let's see, for any week. Any week of the year taken at random. So week, that's going to be 7 days, right? So our trials is going to be 7. Okay. And then the probability that that bus is going to be, let's see, being on time. It says it runs late 2 out of every 5. So if it's late 2 out of 5, that means it's on time the other 3 out of 5. So that's going to be 0.4, and this is going to be 0.6. So we want to know what's the probability of the being on time. So we're going to use the 0.6 here. So probability is 0.6. And then our x value, we want to know 7 out of 7. Okay, enter and push paste. And we're going to push enter one more time, and that is going to be 2.8% of the time. Okay, there we go, 0.28 or 2.8% of the time. So not a very good chance. What's the probability that the 8 a.m. Bus being on time on any 6 days? So it's going to be, let's see, on any 6 days. It's hard to tell if that's exactly 6 days or at least 6 days. It says it on any 6 days, so I'm going to go with this exactly 1. Let's see if that's what our textbook meant to do. Okay, so really that would be a binomial PDF again. So we do second variables. Okay, we do that. Trials are 7. Probability is still 0.6, and now we want to know what's the probability it'll be on time 6 of the days. Push paste, and we get that. Now it's up to 13.1% of the time. Okay, equals 0.131, and that is what the book intended. So 13% of the time it'll be on time on 6 of those 7 days. Okay? Okay. Let's take a look at another one here. Move this over here, give us more room for our calculator. In a multiple choice test, there are 10 questions. Each question has 5 choices, one of which is correct. Raj knows absolutely nothing about the subject and guesses each answer at random. Given that the passing mark is 70%, to determine the probability that he's going to pass. Okay, so now he's got to get 70, 80, 90, or 100. So he needs to have at least, so we're going to do this one right here. It's got to be at least 7. Okay, so I'm going to write this up here to kind of help us understand this a little bit more. So the probability of x being greater than or equal to 7 correct is going to equal 1 minus the probability that x is less than or equal to 6. Okay, so this is what we're going to figure out. And we're going to take 1 and subtract that. So that's going to be our binomial CDF. Okay, so second variables. Going down to, I believe it's B, binomial CDF. There are 10 questions, so there's 10 trials. Probability, if it's 1 out of 5, equals 0.2%. Sorry, 0.2, which is 20%. Okay, so our probability is 0.2. And then this one here, we want to know the probability of getting 6 or less. So we're going to put a 6 in there. Enter, and then paste that thing in, and there is a 99.9%, 0.999. So that's going to give us, subtract those two, and we get 0.001. So he's got 0.1% chance of passing, which is not good at all. Okay. The book rounds it to a different number there, but we're good on that one. So very, very small probability that he's going to pass on that one. Okay, moving on here. Number 6. During a season, a basketball player has 85% success rate in shooting from the free throw line. In one match, the basketballer has 20 shots from the free throw line. Find the probability the basketballer is successful with all 20 free throws. Okay. Okay, so this is an exact number, so exactly 20. So we're going to use this one here for part A, right? So we'll do second variables, move down to binom PDF, which is the A here. So 20 shots, so that means there's 20 trials. Probability of them making it is 0.85 because that's 85%. And then we want to know what's the probability he's going to make all 20. Paste, and enter. That's 3.9%, so we'll put 0.0388. Okay, so not great chances, but it can happen. It's almost 4%. Okay, and then C, between 14 and 17 inclusive. So the probability of making 14, 15, 16, or 17 free throws. Okay, now this one's a little trickier because it's between these two numbers. So what you could do is you could go through and you could use this binomial PDF to find 14, 15, 16, and 17, add them all together, and away you go. Or what we could do is we can actually go through and say they're not going to make more than 17, so fewer than 17. So we can do this one right here for fewer than 17. Okay, so we want to know when x is less than 5, so it actually does not include 5. This one would include 17, so we're going to put 17 in for this number right here. So we're going to do binomial CDF. Okay, so second variables. I tested this out a little bit earlier just to make sure that it works, so I actually have some of my data in here. So binomial CDF, 20 trials. The probability of making it is 0.85. And then we want to know fewer than 17, including 17. So we're going to do 17 in here. Paste, and that is 0.595. So it's 0.595. So there's a 59.5% chance that they're going to make between 0 and 17, but we want between 14 and 17. So then we want to know, actually, really, we just did this one here. That's why that would make more sense. So at most 17, so that's what we just did here. And now we want to make fewer than 14, so that would really be 13. Does not include does not include 5. So we want to know what's the probability of getting 13. Okay, 0 through 13. So we would do second variables. Binomial CDF. Still 20 trials, still 0.85, and we want to know what the probability of getting, really, it's the fewer than and including 13, right? So we want to turn this to 13 and paste, and we get 0.022 minus 0.022. And when we subtract those two from each other, we get 0.573. And that is the correct answer that we're looking for. That would be the same thing again if you found the probability of getting exactly 14, exactly 15, exactly 16, exactly 17, add them all up, you would also get this as well. But this is 2 less calculations, so I kind of like that one a little bit better. Okay? All right, let's take a look at some more here. Number 10, Shelley must pass through 15 traffic lights on her way to work. She has a probability of 0.6 of being stopped at any given traffic light. If she is stopped at more than 11 traffic lights, she's going to be late for work. Find the probability that Shelley will be late for work on a given day. Okay, so here's our info here. So find the probability Shelley's going to be late for work on a given day. 15 traffic lights, probability of 0.6 being stopped. If she's stopped at more than 11 traffic lights, she's going to be late for work. So this is going to be, we want to know the probability she will be late. So this means we want to do this one here because this is the more than. Okay, so we want to know what's the probability she's going to be stuck at more than 11, well, actually be more than 10 lights, right? So we really could do stopped at least 11. Okay, which is really kind of the same idea here, but okay, so let's do that. Let's do, what's the probability she's going to get stopped at least 11 lights here? Okay, so it's going to be binomial CDF, second variables, which is our distribution. Go down to binomial CDF. Okay, the number of trials, there's 15 traffic lights, so there's 15 trials. Probability of getting stopped is 0.6. And we want to know when she gets stopped at 11 or more. Okay, so at least 11. So let's see. If we want to do at least 5, we want to put the one less than that. So we're going to put 4 in there. So we want to know what's the probability of getting stopped at 10 or less. So we're going to do 10 here. And then we're going to find the complement of this. So probability of her making it to work, will not being late for work, is 0.783. So we do 1 minus 0.783. And that is going to give us, so we just do 1 minus our answer, and we get 0.217. So 21.7% chance she's going to be late for work. Okay, I just realized that I did one little mistake in here, which is going to mess everything up. So let's fix that. It should be, according to this here, let's see, it's got to be stopped at more than 11 traffic lights. Okay, so that's more than this here, so more than 5. On this one here, we actually got to put the actual number 5 in there, so I got to put 11 in instead of 10. So second variables, come on, there we go, enter. And then we got to put 11 in here instead. And that gives us 0.909. 1 minus 0.909, which ends up giving us 0.90. Oops. Pardon me. 0.0905 if we didn't round that off before. Okay. All right, and then C here. Shelley wants to increase the probability in B to at least 80%. So she decides to leave home a little earlier, so now she must be stopped at more than 12 traffic lights in order to be late. Has she achieved her goal? Justify your answer. Okay, so Shelley wants to increase the probability to at least 80%, decides to leave home a little earlier, so she now must be stopped at more than 12 traffic lights in order to be late. Has Shelley achieved her goal? Justify your answer. So now we're more than 12, so we're going to use this right here, more than 12 here. So if this was more than 5, we're actually going to put 5 in here. So I went through and did that already just to kind of try to save us a little time. So 15 trials, 0.6 probability of being stopped. And then it's got to be at least 12. So that gives us a 97.3% chance. 0.973. It says she has to now be stopped more than 12. Has she achieved her goal of being on time up to 80%? So yeah, that's definitely over 80%. Now, back of the book has it as 87.2%, but let's see. I'm going to disagree with that and go with this one here because I am not sure how they would have gotten 87.2. So anyway, this should work out here. Okay. That's all we have for the 14E assignment. If you have any further questions, please feel free to ask. Thanks. Okay, I take it back. I went back and double checked on this one here. She decides to leave home in order to be, let's see. The probability that she will be late in this is the probability of her not being late on any one given day. So what the book figured out is like an entire week. But you know what? I'm not seeing anywhere in here where it says something about be late for work at all during the week. But if we do take that 0.9782, this number here, and we take it to the 5th power, so meaning that she's got to do that all 5 days, that's where we get 0.872 Okay, so that's where they must have came up with their answer. But again, it doesn't say anywhere in here that it's for an entire week. So I'm still sticking with this one here. Okay, all right. All finished off. If you have any other questions, please feel free to ask. Thanks.